The last one we got here looks like something that's pretty close to a quadratic. Y squared minus 8x minus 16 is equal to 0. The piece that's different, though, is that I've got an y and an x in the same portion. It'd be really nice if this were to have been an x squared, because I know there are factors of negative 16 that add up to negative 8. But we want to convert this to polar. And when we've got polar, we're going to do the r sine theta, r cosine theta. And let's see if there's anything we can work with to make it all the same so I can factor down. So let's start with the y squared. Y squared we know is going to be the same thing as r sine theta, quantity squared. X is the same thing as r cosine theta. Minus 16 is equal to 0. So r squared sine squared theta minus 8r cosine theta minus 16 equals 0. Now, just as we did in our previous chapter when we solved for equations, we want to have everything in terms of this middle term. It'd be great to have everything in terms of cosine of theta. Is there a relationship for sine squared of theta that's tied to cosine? And we know that 1 minus cosine squared of theta is sine squared. So just as we did before, we'll do a substitution step. R squared of theta is 1 minus cosine squared of theta. And we'll distribute the r squared in. So r squared minus r squared cosine squared minus 8r cosine theta minus 16 is equal to 0. This right here I can almost factor if this r were thrown to the other side. So let's get that r to the other side. So negative r squared cosine squared theta minus 8r cosine theta minus 16 is equal to negative r squared. And then we can factor out a negative 1 or multiply through by a negative 1, so then everything's positive. R squared cosine squared of theta plus 8r cosine of theta plus 16 is equal to r squared. Now over here I can see I've got factors of 16 that add up to 8. And this is one of your perfect square trinomials. So this one we can factor down to r cosine theta plus 4 quantity squared is equal to r squared. And then r is equal to plus or minus r cosine theta plus 4. We're almost done. We've got a plus or minus equation that we need to solve for. So I've got two equations. So the first one, r is equal to r cosine theta plus 4. The other one is going to be r equals minus r cosine theta plus 4. So the first one, let's drop the parentheses. The second one, we've got to distribute the negative in. And now let's move all of our r terms to one side so we can factor out the r. So right here, let's move our r cosine theta to the other side. Over here, we'll move our negative r cosine theta to the other side. Here we can factor out an r. And over here we can factor out an r. And then finally we'll divide both sides by our quantity. So r is equal to 4 divided by 1 minus cosine of theta. Or r equals negative 4 over 1 plus cosine of theta. Had quite a bit of math right there. Sorry I'm getting a little crooked. Let's get that straightened again. Quite a bit of math right there. So we want to confirm, is y squared minus 8x minus 16 the same thing as these two equations? Now if you remember from last year, something that's squared is going to be a parabola. And since this is a y squared, it's going to be a sideways parabola instead of an up and down parabola. So let's plug these into our calculator and see, do we get the same thing both in polar and rectangular form? So with this first one, we want to solve for y. So y squared is equal to 8x plus 16. And then we'll take the square root to both sides. So y equals plus or minus the square root of 8x plus 16. So in y1 and y2, we're going to put in square root of 8 plus 16, then negative square root of 8x plus 16. So let's pull these guys on. Change my mode back to functional mode. And I want the square root of 8x plus 16. And I want the negative square root of 8x plus 16. Can't really see that too well. So let's go back to zoom and choose number 6, zoom standard. And sure enough, there I'm going to have that sideways parabola that we predicted. So we'll change our mode. We'll head back to polar mode. And I want to plug in these two equations now. My 4 divided by 1 minus cosine theta and my negative 4 divided by 1 plus cosine theta. So the first one is 4 divided by 1 minus cosine of theta. The second one is negative 4 divided by 1 plus cosine of theta. And if I go to graph, sure enough, I get the same parabola that I had in rectangular form. Once again, if I choose to turn off one of these, let's say I turn off R1, there's my parabola being drawn down and then coming back this way. If I do R2 turned off and R1 turned on, well, there's my normal drawn parabola. So with both of those are both equivalent ways to write the exact same equation that we needed up here for both of those in order to work.